Good morning, good afternoon, good evening. I am very happy to welcome you to today's Developer Experience Office Hours. We're going to be talking about the service binding operator this morning. And this afternoon, wherever you may be. I'm Chris Short, Principal Technical Marketing Manager at Red Hat. I am using my standing desk today because standing is good for you. But I'm joined today by several friends of mine. Let's just go around the horn. Ryan, I'll start with you. Ryan, please introduce yourself.
Hey, this is Ryan Jarvinen. Ryan J, most places online, developer advocate in the OpenShift DevRel team. Happy to be here and excited to talk about operators. Let's see, Brian.
Hey, how's it going, guys? My name is Brian Tanis, and just like Ryan, I am part of the same team, so OpenShift developer advocate. And excited. We're going to talk about the service binding operator. It's going to be an interesting discussion.
Yeah.
Hey, my name is Natale Vinto. I'm in the same team of Brian and Ryan, and happy to talk about service binding operator with this new background with the garden here. I had to change my workstation, so happy to be with you talking about these new cool things available in the OpenShift 4.5 developer console.
Nice. I like hearing about. Also, updates on my desk situation. I have a brand new chair or a standing kind of stool thing that I can slightly move around on but stay standing. So I'm also doing the standing desk thing like Chris.
Yeah, I'm not sure if I'm liking the mat or not the mat. I don't know.
Yeah.
We'll figure it out. But I've got the desk. I might as well use it.
Yep.
So
take care of yourself, folks.
Yeah, like seriously, you're at home. You're stuck. Stay healthy. Like that's the biggest thing. So service binding operator. Yeah. You want to talk about that today? We talked about it. I think we touched on it last week real briefly. Or last time we were on 2 weeks ago, real briefly.
Last time I remember really getting into this topic was when we were talking about Odo, and I remember seeing, especially with Odo, if you're creating new resources, now they get a list of labels slapped on them. And if you do linking with Odo, there's also additional labels that show up. And this labeling scheme is consistent with how the SIG apps effort and other folks in the upstream community have kind of elected to do markup for microservices that are part of a collection. And so the service binding operator is intended to work within those kind of expectations that the community's been putting out, and set up labels and expose other other content into the running pods so that they're aware of each other and have more support and more than just the native kubedns kind of service discovery, which if you already know the service name of another microservice, you could try to target it directly, but that's also a lot of knowledge that you may want to distribute in a more clear and concise way, and putting them in via labels or a secret or other details like that can help make it happen. So
nice.
So
if you have like an application that you're building, you're working on, this microservice or whatever, and you're using Odo to build that and run it and test it and all that stuff on OpenShift as you're developing, you want to connect to something else, it's automatically adding these labels, or do I have to add like a switch whenever I'm running Odo? Like, how does it know that I need to connect to a database, or I need to connect to something else, or whatnot?
That is a excellent question, and I was hoping that we would figure this out through trying it. Chris
Nice.
Short has set up a cluster. Brian may also have a cluster available. I know us folks here on the stream have an internal Slack that we can kind of collaborate in the background if needs be. But we were hoping to demo for you, the audience, a live, real, in-person interaction with the service binding operator. If you have any questions along the way, please feel free to drop them into the Slack. We want to make this a conversation for the community and not just us.
Drop it in the chat, not Slack. Sorry, folks.
That's right. That's the one.
Any
Sorry.
chat. So if you're on YouTube, you're on Facebook, you're on Twitch, drop it in the chat. We'll pick it up and we will get it answered. Don't you worry. All right. So whose cluster are we using today?
How about this? Does anyone want to volunteer to drive? If not, I will do my best to, I am already logged in a cluster and I can see if I can set up my screen sharing. I've been having some issues with Silverblue, but I can give it a test unless there's any other volunteers in the channel here.
Brian, I can hand you the same cluster details if you need it.
It doesn't matter. It doesn't matter to me. If you want to try, Ryan, go for it.
Yeah, I'd say give it a try, man.
All right,
let's see if
let
your
me
setup
see
works.
how this does. All right, this is my first time hitting the screen share button.
Oh boy.
Let's see. Share screen. I have a pop-up that says cannot share. We only allow Wayland on GNOME with Ubuntu 17, Fedora 25, and above. If your OS is not on the list, please use X11 instead.
Yes.
I should have yeah.
Yeah.
It's fine. Let me see if I could. I should probably be able to.
I sent Brian the deeds. Yeah.
have-
So good to know that you need to log in as Xorg with Silverblue still.
You know, I've been warned in the past, and I haven't actually done the log out and log back in deal yet. I'm actually very happy with this Silverblue setup overall, but there are a couple times where you want to go and customize things, and it encourages you to stick with good practices for security. And I'm
RPM OS tree doesn't play games.
yeah. It doesn't screw around. It
plays no games.
Right. Yeah. I can't cheat. What? Cheating is how I work.
I am a hacker, damn it.
Yeah. So true. So true.
Oh man.
Okay, so I'm just logged into my cluster.
Sweet.
And I'm also using Silverblue, but I've learned that lesson a long
Oh
time
man.
ago.
a better person than I am. Yeah. Wow.
No. Always switch to X11.
Yeah.
Although some of the new browsers or latest updates to some of the browsers let you share, like maybe Chrome, Chromium, like newer versions. Firefox is somewhat depends on the app.
I think if you're on the Canary version of Chrome, you might be in better shape, Ryan, to be honest with you.
Well, I'm using the desktop Zoom
Flatpak app that probably
Flatpak. Yeah,
you got to download the RPM.
Okay.
That might be your problem.
That could be your problem too. Yeah. So for Fedora users out there, download the RPM for Zoom. Use Xorg 11 for Zoom for screen sharing.
That'll clean up your screen share issues on Linux, no matter what.
All right.
Yeah.
But whenever that Wayland support comes, that's going to be awesome.
I can't wait. Yeah. I really can't.
Oh man. It's Upstream's fault.
Yeah, right.
Pull request accepted.
So you guys could see my screen, right? So
yes, sir.
I'm logged into my OpenShift cluster that's running on bare metal. And I was playing with this a little bit already, so I have a project set up. And I think probably the easiest way, I'll just show the simplest service binding operator demo ever. And I'll show you how this is going. We could figure out, if we want to make it more complex later, as we're going. But just to get an idea of what this does for you, is it removes some of this complexity of thinking about, well, I have an app that I built. It needs to talk to a database. I need all of these things. I need credentials, I need IP addresses, I need all of these things that are related to connecting to the database, right? So I have an app. It's a Node.js app that's running. I deployed this using this add button here, and I deployed from Git. In here, I just put in the Git repo URL, and it automatically decided this is a Node.js app. From there, I didn't change anything else. It was a very simple deployment, nothing's crazy. So that's deployed. You could see the app, it got built, it's running, it's a solid blue ring. We could see all that.
Can we take a look at the labels that are on it?
Yeah.
From that topology view?
Yeah, we can. So this is what the app looks like right now. Let me show that. This is the important part, right?
Yeah.
It's reaching out to a database, but there's no connection. So it doesn't know, right? I decided how, that's connected. Let's look at, so in the deployment, you're gonna go into, see labels that are in here.
Many labels.
Let's see.
So it got all of those labels kind of for
Yeah.
free out of the, well, they were pre-packaged into the catalog.
Node.js
Whenever you
catalog,
picked Node.js,
Part of
whoever's
Node.js.
the team lead for this Node.js, slap these labels on. Right?
Yeah.
Right.
Yeah, yeah, exactly. I
Or
mean,
maintainer,
all those
whatever,
labels popped up. I guess those labels are all labels that you would get from a regular build, right? Or I'm pretty
That
sure.
is most likely correct. Like, I think anyone who's using the OpenShift provided Node.js builder will automatically get a decent amount of labels. I think if it's a specific prepackaged, like try this Vue.js app, whoever's maintaining that Node.js launcher might throw in additional labels, and anyone who has their own kind of specific apps they're maintaining, if they constructed them using either our web UI or using Odo, they're probably going to get a lot of labels put in for free. But that's definitely something that you could add more of to help make sense of your app. But we want to try to give you best practices on what labels make sense from other folks' perspective within the Kubernetes community. So I think what we're giving you most likely in the OpenShift catalog is things that are a mix of what is consistent with upstream, plus probably a little bit of embellishment just to give you additional meaning to what you're looking at.
And
Like,
Serena in chat points out,
what's the app, what's the instance, what's the runtime, what version of runtime are we using? Those are labels that like we're giving you so that you could see, and determine using the Kubernetes API if you need to, what is actually going on with this deployment.
so Serena's pointed out a ton in chat, right? Like if you are using the import from Git flow, there are things that are automatically generated by the console. For example, a label is applied that says, yes, this was generated by the console, as well as the application that's associated with it. And it looks at the runtime to apply that label and define the logo in the topology view. So yeah, there's a lot of analysis happening when you do that import from Git to apply labels too. So yeah.
You could also custom as you're putting them in. If you have custom ones that you want to add, you could add them in here. There was a little label button that I clicked down at the bottom, at the very end of the deployment. And in here, I could specify label 1 equals test, for example, and that would pop up in there. So you would see that if you haven't seen that. Awesome. So that's the app. The app's deployed. And like I said, it's just a simple app. It's looking for a database. If it doesn't have one, it still works. But I can't really add a fruit to my application that I have, right? It's not going to work. It's going to give me an error. So that's the problem. Obviously, there's no database connection. I didn't specify anything about a database, just the app whenever I developed it, or whenever, whoever developed it, the Red Hat developer team, there's a particular place that they're, looking for database and all that stuff. Anyways, that's there. The next part was deploying a Postgres SQL database. And what I did was I installed a operator to deploy databases. There's details on how to do that in a link that I'll share out. That's part of the documentation for the service binding operator. But basically what it lets me do is if I go into the administrator view, I could see the installed operators that I have. And I could see that I have a PostgreSQL database operator that's available to me, right? I deployed that out into the OpenShift operators namespace, right? Just like it suggested when I went into the operator hub and looked for PostgreSQL. So I installed it this way and followed the steps there. Once that's done, I deployed the database. So I went to this PostgreSQL database and created an instance in my namespace. So that's all the setup that I've done so far. I haven't done anything else. I just said, hey, I need a database. And I just said, hey, I need a Git build for my Node.js app. That's it.
Wait, was there sorry, I was looking up some things in another window and I blanked out for a second. Did you say you installed the service binding operator as a prerequisite?
Yeah. So that was also a prerequisite. Good call. Good call. Yes.
Yeah. Yeah.
Cool.
So,
I wanted to make sure we didn't skip over that one.
Good point. Yes, that was also needed. So
that's something you can find. Is that available generally on Operator Hub? I need to double check that.
I can check that real quick.
That is available. That will be available in Operator Hub. So just search for service binding operator, and that is there. It's a community operator. But it is available on the Operator Hub. You don't have to add any additional operator sources. And on here, when you install it, it will ask you, hey, do you want to install this for all namespaces? Which is what I did in this particular example.
Cool. And then
so
that lets
those are the prereqs. Sorry about that.
Yeah. Cool. Awesome. So that service binding operator has a special operator controller code that if you install it cluster wide, is then going to watch for certain signals and then apply labels or take additional actions to notify these services of each other beyond what you would get from normal Kubernetes namespace discovery and kind of the minimal service discovery via kubedns.
Yeah.
Thank you for pointing out that it's a little bit more than just the average namespace kubedns type stuff.
Yeah. But this often is going to be something that, as if you're on a team that's working towards an OpenShift environment, hopefully you can expect that whoever set up the clusters for you, if you're in a large corporate environment, most likely has already installed and enabled this service binding operator if it's a prerequisite of part of your workflow. If not, talk to your admins, make sure they know this needs to be pre-installed on clusters where you do your work.
It'll save them time too.
Yeah, exactly. That way they don't have to deal with, connecting things, doing the things that operators do. And if you do have access, so, you're working on OpenShift, the way to find out is within your namespace that you're creating or your project. On here, you could see these are all of the the cluster-wide operators that are available, and I could roll out that are installed on the cluster that I have running over here, right? So I went and installed these operators already. So if I need the service binding operator, well, there you go. It's available for me. If I need CamelK, if I need Postgres, the database, like what I used earlier, I could roll that out with an operator that was already pre-installed. So that's how this list already, has a couple different things that are in here.
Why is everything up to date? There's no updates available?
Shocking. Did you update this thing this morning?
Isn't that the whole point of operators?
Yeah,
update themselves.
Yeah. I'm almost used to seeing a system where it's like 15 system updates pending. You better click on this and you know, and I'm like, oh geez, maybe later I'll do it. And
I will say the one thing with operators and OpenShift that you have to think about, at least right now, you know, maybe OLMs, you're working on getting smarter. It does a ton, which is awesome. But so I've started out with a 4.4 cluster, and you can see I've done a couple different
Ooh.
updates here. Everything's went smoothly, no problems. I'm on 4.5 right now. So
Yeah.
the latest
Nice.
version. How I did that was I changed the channel. I don't want to take up too much time, but I just switched the channel and did the update. Talking about operators, that happened, cluster updated, everything worked. The services and things like that that I had worked, no big deal. But I do have a couple different operators that are dependent on the version of OpenShift that I'm running. So this is something for the admins of OpenShift clusters, make sure that you watch out, because I'm not sure how widely this is known for everything. It depends on the service. So for example, the serverless operator, for one, just to point one out, has a channel for 4.5 versus 4.4. So even though they're the same version of the thing, there could be some differences at some point, right? So make sure that you also double check the operators you install and make sure that the versions match together. Not all operators are like that though, so make sure that you pay attention. The serverless one is one, for example, but say the service mesh one just has a stable channel. So that's okay, you don't have to deal with it. So anyways,
Yeah.
when you do a major upgrade with OpenShift, which just recently happened on mine because OpenShift 4.5 came out, I just updated the cluster and then went through and double checked all the different operators that I have. Maybe at some point that whole step will be automated with the operator, but I don't know.
That's a good point, though, because Waleed asked yesterday in chat during one of the live streams, right? Like, couldn't he run like OpenShift 4.5 and still stick with the 4.4 operators due to some, you know, business requirement? And basically, I was like, that's unsupported.
Yep.
If it works, good luck, you know, right? Like, it might work, but that doesn't mean it's supported, right? Like, so just keep that in mind, right? Like, if you have been running 4.4 on a 4.4 service mesh on a 4.5 cluster and having issues, that could be why.
Agreed. And that being said, sometimes you don't have the option. So the pipelines operator has not been updated yet, or at least my cluster hasn't gotten that update. I'm pretty sure it hadn't been updated yet with a new channel, right? So I still have to use the 4.4, you know, older channel, I guess, which is the current channel. But anyways, it's somewhat confusing right now, but things, you know, make sure that it matches whenever it can.
It's confusing because you're on the fast channel, I think, too.
That's
like
too.
you're way ahead of schedule, right? Like
exactly.
That's why everything's up to date. Yeah, you're on maximum updates right now.
Yeah, I can't get any more updated because we're already as fast as we could go. Okay,
bleeding edge. Yeah.
All of that stuff being said, I have the service binding operator installed cluster wide. You can see I got a couple different things running in this operators project. Let me switch back over. So I've got all of the service binding operator. I have my application that I just copied the Git repo in and had OpenShift build it. And then I deployed a Postgres SQL using the operator. I didn't go in here and do add from a database because this is going to use a templated version of the database. And we need to be using databases that are operator managed for one, at least to make it this easy.
To make it this easy and so that you get updates.
That too.
So you can manage updates more effectively. Yes.
Like you saw, the app did not have a database connection. All I'm going to do is hover over here, drag the arrow over, and you can see it says create a binding connector. If I had a database that was built off of the template, for example, let's just add it here.
Yeah, why not?
Why not? You can see what it looks like. So this is the one that we don't want, at least as at the moment. We'll see how this stuff ends up. But you can see visual connector. That's not the one we want. We want a binding connector. So anyways, I'll create that binding connector. You can see that that app is going to
Things are
be
happening.
redeployed.
Wow. Dance, dance, boogie.
Yeah, once that happens, let's see, it's still not deployed. It might take a second. But what will happen here is this will pass the credentials and all of the different things that are needed for the app and that database. It handles that connection and all of the different metadata that's needed to be able to make that connection automatically.
Nice.
You just drag and drop, and that's how you Kubernetes now?
That's it.
That's how you train.
That's it. You don't need anything else. That's it.
If you don't need anything else, I'll be over here.
I didn't see any YAML in that. Hold on.
There
Wait,
was
yeah.
no YAML. That's how it goes.
So the order of operations was service binding operator. Well, you created a namespace, first of all. You installed the service binding operator. You installed a Node.js app. You installed a Postgres operator. And then you just dragged and dropped the connection over, and it should have all the info it needs.
That's it.
Is it running? Is it working?
That's it. I know.
I
Don't
mean,
look at me like I'm crazy. This
as
works
Langdon
last night.
points out in chat, your spacebar will get lonely without YAML.
So as an app developer, I would immediately be like,
Still
bullshit,
no.
there's trickery involved. Show me the Node.js code. Because
Right.
I know I need to write something that is reading from something the service binding operate. Like there's some extra glue here, right?
Right.
So what's going on?
What do we have up our sleeves?
What's this?
Well,
What's the trick?
Yeah.
Yeah.
I'm
So-
sure there's something that folks need to know as far as their application code. Is it just work with best practices as per the Helm community for reading and writing from labels? And that's how you know what other apps you need to be aware of. Hi, Josh. Josh Wood just joined.
Welcome, Josh. Please introduce yourself.
Hey, everybody. I'm Josh Wood from the OpenShift Developer Advocacy Team, co-author of a recent book about operators, and half an hour late to our live stream. But I'm
Oh,
here now.
you're fine, buddy. Don't worry about that, man. No big. We still love you.
No, great to have
thank
you
you.
here. Hey, let's
I'm
catch
just
you up.
trying to- I'm just
So
trying to
you
get
mean
let's
you
bring you up
wrote
to
a
speed
book
here.
about this
Ryan and see what
operator
we're
stuff?
talking about. Was that a question for me, Brian? I didn't
Yeah,
hear you.
obviously.
Yeah. Give us a link to the book.
I got it. I just dropped it in chat.
Yeah, right on. Thank you, Chris.
So you can get a free copy of the book. Just go to the, if you're in chat right now, just go to that link, get a free copy of Josh and Jason's book. It's a fantastic book. I have a copy of it now, thanks to Brian. I use it routinely to find and figure out operator-y things. So yeah, it's pretty awesome.
Right on. Thank you, Chris. I do hope it's useful, and I think especially there's some really hands-on stuff in the middle chapters about building these things. Interestingly, today's topic is one of the things that that is to say the service binding operator is sort of this idea of an advanced feature that we built on top of some of this operator machinery that we would have loved to examine in the book, but really the feature wasn't complete enough in time to match the book schedule. And we wanted to focus the book down really on that basic operation of building things with the Helm, Ansible, and Golang support in the Red Hat operator framework and SDK. So hopefully or possibly in the future, we'll do an expansion into a second edition or even another volume that focuses on kind of this higher level and things you build out of the operator machinery like OLM and bindings between services.
Yeah, we were just looking at OLM and all of Brian's updates that he had going on in his system, and the kind of slight complexity or decent level of complexity involved around doing OLM updates when folks are also subscribed to certain primary channels. And do the operators also have each of those channels available? Hopefully, but I don't know. Yeah.
Right, because a lot of that is at least currently tied together by convention, like a matching name.
Yeah.
So I think convention is a good placeholder as a wider community or ecosystem kind of figures out how that's gonna work a little more formally and has a specification around it instead of just that convention. That I think will help simplify that. But nevertheless, the problem domain is fairly complex here because with OLM we want to be able to describe not just a chain of releases represented by a subscription, and then a channel of the cadence of those releases within that subscription, but dependencies between different streams of subscriptions, part of which is the service binding stuff we're talking about today, but there are also generalized streams of operators that describe dependencies such that when you install one, you want two or three others that go with it. Those are all like actually do complicate the problem domain even outside of how much we can simplify the solution in the software part.
Yeah. Package managers are hard
Yeah.
work.
Yeah.
Yes, but there's it's an area where we're basically taking well-known concepts and kind of moving them to a new space. So
Yeah.
the package management side of this and the dependency management, while it has remained complex, is increasingly well understood. And there's a lot of examples on other platforms or with different operating systems that we can learn from to apply to how we design both OLM and the description of dependencies between these things.
Yeah. Now do it on a distributed system though, and that's like
Yeah.
that's why it's tricky.
Yeah, well, and then potentially with some clusters being air gapped or it on the other end of that spectrum federated in different ways. So there's all of those complexities as well.
Mm-hmm. Yeah. I wanted to take. Oh, Serena in chat mentioned that you can right-click on a Node.js app and then tell it which database you want to add, and the service binding operator will automatically just leap into action behind the scenes, so that when the database arrives, all the linking and labeling and everything has basically already been done for you. So that might be interesting to look at from the UI, right clicking on the Node.js deal.
Yeah, that's actually super cool. And so and you'll forgive me if I backtrack for the audience a little bit here, but if we talked about the mechanism of how this works, like this is a really cool example of what we can, the kind of user features we can build on top of it up at the UI level. You can do this right click and just get the service you want, right? So this happens because the operator that runs one of these potential backing services is annotated with it's annotated with what it can provide to a service binding request. So there could be 3 or 4 annotations in an operator that says Postgres database or Postgres database of a version, and that's how the service binding operator discovers what operators can fulfill a certain binding request, like the one you're about to make through the user interface.
This user interface has evolved quite a bit in these recent releases of OpenShift over 4.4 and 4.5, and really there's a lot more to look at. It has recently won an award. In fact, I forget the name of the award, but congratulations to Serena and team who's been chiming in chat here.
Yeah,
excellent
no
work.
Seriously.
Really cool to see all this stuff come together. And definitely, if you're in the chat, make sure to check back next week. Serena is on every alternating week to share more upcoming demos and get your early feedback on this stuff. She was saying, I think visually here, there's the core Node.js app and then maybe another ring for the deployment. And so maybe clicking on the deployment there, it looks like there you could do add more right there visually.
Yeah, so I was trying to look. So if we right click on, say, the app.
So Serena says click the deployment, right click the deployment itself.
So right click on the deployment. So we've got storage, there's no database. If we drag the arrow out, we could bind this to another image, but not necessarily to the operator.
Okay.
Huh.
Weird.
Is that
I wonder.
Or to the
No.
database.
Yeah.
Hmm.
Huh.
I wonder if it's
Well,
because there's a database in this pod that it won't spin up another one. I don't know.
Maybe.
Or user in this project. I mean,
I guess I could try.
use the arrow from the DB and then add the Node.js side.
maybe go the other direction.
Yeah.
Yeah. So anyway, I wanted to say both congratulations to Serena, but also kind of a heads up that this has been under lots of active development. And if you have feedback, definitely join us Tuesdays during this hour. Serena and us, we would love to hear your feedback as we work through this stuff. So
yeah, I mean, a big part of the reason for this channel is to connect with everyone out there, in the world. So if this is another feedback venue for us as well. So we hope that if you have issues or ideas or suggestions for the console, please come to these office hours and let us know if you want some features added or having some issues with something. We're here.
I might be on a whatchamacallit, like an older version of OpenShift or whatever that I don't have. Serena lives in the future. We all know that's true.
That's true. Serena does live in the future.
So just so you can see that when the app is connected, we do have a connection, and we can see that like there's, we could save fruits, we could add that. But I mean, literally there wasn't anything that we just connected that binding and it handled all of that stuff for us.
do you have a link to the repo where the Node.js code came from? I'm kind of curious to see if there's what their code looks like for hooking up to databases.
So how I got there and how you could test this out yourself without, deploying your own app. If you want to see it yourself, the same way that I have it deployed, just look up the service binding operator. There's details on Git on what you need to do to get started. There's a couple different examples if you scroll down here. So depending on your own situation, this doesn't just work with PostgreSQL. This works with AWS. It could work with etcd, for example, or what have you. The one that I used is the very top one. And on here, there's details on what you need to do to roll this out. And of course, like what you said, this is Kubernetes. So if you don't want to use the console or you want to form this in YAML, all of this is available to to your YAML's content. Right? You can do whatever you want with all the YAML. But as far as the repo for the particular app, that's available here. And from here, let's see. Yeah, I guess what do you want to see for this particular repo? Should I drop this into the chat?
Yeah, that'd be great. Or what? I could type it in if I could just read the URL at the top. What is it? Red Hat something.
It's in the chat. So
okay, perfect.
You got it.
Awesome. Thank you.
Also, if you go back to the topology view, if you are curious about the code, you can click on the little Eclipse chat icon, and you were able to edit this code inside the cluster with auto integration. So you can code test directly from the browser inside OpenShift. So you can also work from there with the dev file mechanism of Eclipse code ready workspaces. So not only developing connecting things, but also developing directly the code. This 360-degree developer experience that you have in the topology view, it's very cool. It's very cool. Now, for instance, is downloading a Node.js container, packing inside a pod, so you can start coding the Node.js app from there. And then when you are okay with the Auto plugin OpenShift connector, you can push this code to the OpenShift project. And then with the service binding operator, you can connect those things. So you can really have this very nice developer experience from the code to the binding things and going up to the routing system and the networking layer.
And to get that button available, all I had to do was install the Code Ready Workspaces operator onto this cluster. And then when so once that's done, which that was set up, since it determines that, hey, this is a app that I'm giving it a get URL, it knows to bind those two things together to make it really easy to edit that code.
This is
It takes a
awesome.
little bit. If I knew that you were going to say that in Tally, I would have tested and those images would have been pre-pulled, so it would have been a little bit faster. But hey, whatever. This is untested. It works, and it'll pull up, and we'll be able to see the source code.
I found a link to the code that the specific line of code. It looks like it's basically just environment variables in this particular example. And Serena has offered to follow up next week with a demo of basically right-clicking on the deployment to add the database. What we attempted to do but was missing in this UI. She said she's going to bring it to next week's office hours.
Sweet.
Yeah.
Thank you, Serena.
Yeah.
Another nice things I wanted to say about the service binding operator is sometimes, those service discovery is over-engineered in another tool, or you don't need things like service mesh, right? You just need to bind those things. We used to do that in the past with the service broker API, kind of. Now it's come with the service binding operator. So this is another cool things to do the service discovery for a minimal stack and development environment without having their overhead maybe of service mesh. So if you don't have service mesh, this is another cool things to connect your application.
Where's the database?
Oh, let's see. If you go in libdb index. So right up at the top, there's all those, they're pulling things right out of the environment. So those ought to be useful if you just open up a live terminal and type in env. You should be able to see the same things within the Node.js container.
So let's see, I need to go into this project. So on here.
Yeah, if you open up a pod.
There we go.
And then go, yeah. Ooh.
Yeah, I do not know what's going on with this.
Go back one screen. I saw terminal on the past. Yeah, this has moved around a little bit recently. So yeah, the Node.js one, and then yeah, there's terminal. And then if you type in env, you should get the environment variables, and there's a couple in there. Yeah, database password, database, yeah, bunch of database config map, and so there's probably also a config map, or there may be a secret that's mounted somewhere that has this information in a more structured way. If you needed something more than just key values, but it looks like this app is architected primarily to read out of those environment variables in order to take advantage of the service binding operator information.
Right. Cool.
So that was it. That's what was hidden up.
That's what's hidden up your sleeve?
Yeah.
Nice.
So the database, when it got rolled out, it has a config map that has, what the username is, port, that stuff. So
got it.
The operator for the database exposed that config map, which maybe that somehow gets connected.
Cool.
Awesome.
That's ultra easy demo. I mean, it's literally a 30-second drag and drop. There you go. But that saves a lot of time whenever you're working on applications, deploying stuff, right? You know, how do I have to usually go in and manually type, you know, the database is this particular thing, or add that to YAML and have a config map and manually tie these things together. This does all of that for me, so I don't have to think about it. It just automatically happens, and I don't have to waste that manual time working on the craft of setting up the database and connecting them together.
As a developer, my instant kind of instinct is like, man, am I missing out on something by
Yeah, it's
glossing
magic,
over
right?
all the details of Kubernetes, or did I just find some kind of secret to allow me to gloss over like a giant swamp of mixed terminology that's conflicting and doesn't quite make sense internally with itself? And if I can somehow bypass that to stay focused on my job, man,
Yeah.
you know, let me step over that landmine and get back to work. And so if you are trying to be productive on Kubernetes, this type of workflow hopefully allows you to adopt all of the best practices, get the most out of Kubernetes and related tools, while not having to waste huge amounts of time learning every single detail along the way.
And writing less YAML is always nice.
It
True
is,
that.
yeah.
And like I said, so make sure if you're wanting to try this out, the one gotcha trick up your sleeve is the database has to be, you know, managed by an operator that I would assume, I guess, you know, exposes certain things or knows about the service binding operator. So there are databases that are available. You could add this operator source. It's part of the set of instructions, like I mentioned, to roll this out on your cluster. So on here we have this operator source that has those databases available to us. It's not just limited to that. Maybe at the moment, I'm not sure, you know, what the ecosystem is which would support this right now. I know that these ones will, and there's quite a bunch in there available. So it's
and so for folks that are writing operators to manage database or file store foundation apps or foundation services like this, I touched on a little bit ago, you know, this idea of an annotation in the custom resource for the operator that can describe basically the elements we were just looking at as environment variables, which is the connection information, authentication information, and what service it provides for those services that a binding operator is looking for. You can alternatively add those annotations to the OLM descriptor for your operator, so that if you expect to be running in a cluster with OLM, whether that's OpenShift or OLM on your own Kubernetes, services can be discovered through that mechanism. And if you want the details about that, if you're working on an operator for a database or a file system, there is a set of operator development best practices at the operator framework. I'll actually try to find the link, drop it in chat in just a second, that gives the details of these two places to place annotations that make your operator describe what services it offers, so that the service binding operator can discover it and then describe that connection info that is put in a service binding secret. So that link is kind of
I know the link you're talking about. I just don't remember where it is, and I'm trying to
I
find
have it actually just wrongly on another machine. So
no. Operator framework.
There we go.
There. Cool. Thank you.
Yeah. So that kind of tells I want to provide services that the binding operator can discover story for operator constructors, as opposed to I want to use services provided by the binding service, the developer side.
So for folks who are more on the architecture side or who are deciding which databases that teams need to standardize on, this is where they need to look. And they could potentially help enforce that using the service binding operator and also maybe a application operator or eventually.
Yeah, eventually you could actually, so Ryan, you actually kind of touched on what I think of at least as two different things, right? So I've worked at a database vendor or in a database community project, and I want to provide an operator that describes itself as a bindable service. And this best practices guide tells you those two mechanisms I described where you can make those annotations. And then there's the side you just mentioned that's also really interesting and is sort of a whole other can of worms, which is, if I'm an application developer and I use one or more foundation services like a DB to back my application, like let's take something simple that everybody knows, maybe like WordPress. It's always MySQL. There isn't really an official PostgreSQL or NoSQL backend or SQLite. So I might want to ship my app in terms of its own annotations that say, I use this service from the service binding operator whenever you install my application operator. And you can deploy a whole stack in terms of the user says, I want to use this end piece, this front end piece that's WordPress or whatever web app. And that thing can actually signal OLM, either pull in a particular database name and version or describe it in terms of a service. And maybe my requirements aren't that strict and specific. Maybe I run across a number of SQL databases, so I just want a SQL database, and the OLM on the cluster and the service binding operator on the cluster can decide to fulfill that with whatever is available. Or maybe I'm tightly coupled to a particular backend file store or DB, and I can name that thing. And then the binding operator can attempt to fulfill that specific request. So that ability to like say, here's a whole application and all its layers and as a shippable stack is something that I know you and I talk a lot about at conferences and with questions of developers, whether we're in the booth or giving a talk, Ryan, is, how do I make a reproducible unit that I can hand to fellow developers, community members, customers? There's permutations of that for each of those levels, and that's kind of what this stuff is really about. Even the really cool demo we have with Code Ready Workspaces that's coming up in another tab. I don't know the mechanics of this thing today, but I do know that the overgoing vision in OpenShift with operators is that even this binding that lets me push a button to open a source code editor can happen because the operator that runs the console has said, I want to bind to a service that edits text on and then attach that to that UI action, right? So even within OpenShift, we can use this architecturally to describe the relationship between components that we deliver as operators, which increasingly is the whole everything.
Yeah.
Right. The whole everything.
The whole, yeah. Well, you gotta now that you have Kubernetes as the new the new platform baseline, you kind of have to rebuild everything from there on up if you want it to be a real portable standard that folks are.
Well, I mean, and I would
usability, right?
Say there is it's even beyond rebuilding certain things, because if you look at, say, your baseline POSIX system that dominated deployment environments for a decade or two, this has never been a particularly well-solved problem at that level, right? Java has solutions to this idea of service discovery and binding, and there's Cobra and other ridiculously elaborate and complicated answers to service discovery and binding. Sorry, Corba, but same. But anyway,
we got to wrap it up pretty soon.
Potentially kind of new ground. Yeah. Like, we can do this a little bit better atop that Kubernetes machinery than just a reimplementation, because at one level, the Unix space kind of didn't solve this problem, except maybe with the idea of post and sockets, right? And then at the next level up, I consider the other solutions at kind of the platform and above the OS level to have been very, very complicated, arcane, or even Baroque. Whereas here we can do, kind of as Natalie was hinting at, like, by convention, this kind of service discovery and binding together that's really based around a name instead of around some formal protocol or something extremely complex and heavyweight.
Yeah, awesome. Well, I think we need to wrap it on up. We're at the top of the hour, and
Yes.
OpenShift Commons is coming up hot on our heels. So
Hot on our heels with cloud native transactions and IBM Cloud Pak for applications with Ian Robinson from IBM. So yeah, looking forward to OpenShift Commons here in just a few minutes, folks. A few seconds,
cool.
actually. So
Thanks
thank you all for joining
attending.
today.
See you next week. Have a great week, y'all.
Thanks, everybody.
See ya.
Thanks, guys. See ya.
Bye.
Hello, welcome back to another OpenShift Commons briefing. Today we have Ian Robinson, Distinguished Engineer and CTO of IBM Cloud Pak for Applications Platform. And he's here to talk about counting on the cloud native transactions, and the future of Cloud Paks. So please take it away.
Thank you. Thanks for the introduction. This session is, well, it's all about transactions. I'd say that people that are deeply into transactions are fascinated by the inner workings of different transaction models and levels of data, the levels of data isolation they provide. That's actually my own history, going back over more years than I care to admit to now, but across, I've been in the past a developer on Kix. I've worked on Corba and OTS standards. I've worked for many years on the WebSphere family of products. I've implemented numerous transaction standards on some of those platforms, although that's going back a little bit now. What we're going to talk about today is some amount of motivation for why we're doing some of the work we're doing with cloud native transactions. I'm also going to be talking about, so some of this is forward looking. So anything that we haven't actually delivered yet is subject to change. So this is a typical IBM disclaimer that just says subject to change. So having said that, people that are deeply into transactions care about the inner workings of different transaction models, most people don't. Most people really couldn't care less about how a transaction works, so long as it does what it's supposed to do. And in the end, transactions are really, I would say, about simplifying how we count things. The more complex a thing is to count, the greater the need there is for a tool to help count it. And counting tools themselves can be quite complex to use. Here's an array of icons of counting tools. I'm not quite old enough to have used a slide rule in college, but I was part of the transition in the UK education system from using log tables to calculators. Both simplified how you multiply, divide large numbers, and I'd say that log tables probably taught me more about how to do maths than calculators did. But who cares? We'd all just rather use a calculator. And that's what people want from transactions. Most of the time, when people are using transactions, they don't even know they're using transactions. They just want their applications to work and to access data with integrity, with the minimum amount of fuss. So let's start off by looking at why transactions are useful. This is a number that you can debate, but you know, whether it's 10%, 15%, or more, it's generally well understood that the vast majority of application code is needed for the error paths. So not only is that a huge blocker on productivity, which is about the happy path, but it's also a huge part of the test cost. And I think everybody here is familiar with the fact that most of the money we spend post-release on application maintenance is about the error path. So transactions to a large extent are all about reducing that. At the most fundamental level, they're about reducing the burden specifically on the application when something goes wrong, and in particular on maintaining the integrity of the data that the application interacts with. So transactions in their most basic form are here to clear up the mess so that applications don't have to. Coming from the UK, every presentation I'm legally obliged to have a picture of the crown jewels. There they are. An enterprise's data are jewels. So the information systems that host that data, and the application platforms and frameworks that provide access to that data, work together, obviously, to provide appropriate levels of isolation and consistency, and they provide the patterns of access to that data. And they do that for the applications that actually make that data valuable. So depending on the application's actual pattern of interaction with the data, the application may have more or less to do in order to ensure that the data that it accesses is maintained in a consistent state. The transaction models that we're going to talk about are provided by those information systems and the application platforms to constrain the way in which the applications interact with the data in order to reduce the complexity of the error handling that the application has to provide around its data access, leaving the app devs to focus just on the business logic. So I've got a repeating theme through these slides where I've got applications represented by blue boxes, and a large part of those applications, again, whether it's 90% or slightly less, represents the error handling. And in every part of this discussion, this is really all about making that red box as small as possible for the application, so that the valuable parts, are the majority of the application. Transactions are everywhere, and most of the time you don't even notice that they're there. So because you don't notice them, you take them for granted, which is why I've got this rather trite picture of an astronaut floating around in space, gravity being one of the things that we take for granted. But before you could take it for granted, you did notice that it was there. And the same is true of transactions. I would say that on every step of the digital evolution of the last 50 years, we have been through a pattern of 3 different phases when new capability is made available. So the first thing that happens is there's a new opportunity for application innovation through some capability that wasn't there before. That's the first thing that happens. As a result of that, the second thing that happens is that new opportunity introduces new complexity in error scenarios, and the bleeding edge applications have to spend an awful lot of time dealing with those error scenarios as a consequence. And so then the third thing that happens is that we introduce new capabilities and strategies for reducing cost of that error handling that's required in order to use the new capability. And we're just going through that cycle again now with microservice transactions cloud. And do stop and ask questions as we go if you want to do that. So right at the beginning, databases and information management systems obviously transformed the way in which applications could use data and make that data valuable. Enterprises, corporations could load their data into these systems, form queries and updates, and access that data with isolation and integrity. And of course, in those days, the database or the information system essentially was the application. Then, where are we now? 20 years ago, a little bit more than that, with the arrival of the internet and online business, 3-tier architectures, and in particular, 3-tier architectures with a Java-based middle-tier application server started to put that data out into the internet. What am I trying to say here? Online shopping applications, electronic business. The beginning of the digital transformation journey suddenly gave us huge opportunities to make that back-end data available in many, many more scenarios than it had ever been before. So instead of applications having to use back-end specific APIs, we introduced new capabilities for those Java applications running in those middle tiers to simplify and standardize the way in which those apps access those data. So, for example, Java EE environments extended database and messaging local transactions into the application realm through technologies like the Java connector architecture, JCA or J2C, depending on how you like your acronyms. That can seem kind of trite and boring now, many years after we introduced that. But if you think about what that did for application developers at the time, it extended the notion of that database local transaction all the way into the application, and all the application was having to do was use connections to that database. So you look up through a data source or a managed connection factory, got your connection and started performing queries or back-end specific operations on that connection. And the fact that there was a local transaction going on with that back-end data system was completely encapsulated and hidden by the connection, which is the only thing the application cared about. So that's an example of the cycle I was talking about at the beginning. You get the ability to use local transactions extended into your middle tier. It becomes a little bit difficult. You have database specific or backend specific APIs. There's error handling that has to go on when you want to roll back that local transaction. And suddenly Java EE, well, not that suddenly, but Java EE comes along, architects nice solution through JDBC, JCA, and it's all hidden. That complexity is all hidden by the connection. So local transactions used to be hard, and then they became easy. So now you introduce a second data source. Local transactions are obviously local to a single resource manager. Now an application starts to interact with multiple backend systems. As those applications became more capable and started to do that more often, the error handling scenarios that the application was responsible for became more complex. You had to now coordinate activities across multiple backend systems, and that's what XA and two-phase transactions again simplified. And through standards like Java Transaction API in J2EE, again, applications could fall back on just using simple connections to the backend data stores and simple APIs like JTA to demarcate their transaction scope, and not then have to worry about any of the coordination that's going on between the backend systems. All that complexity was taken care of and solved by the interactions between the infrastructure components, backend databases, messaging systems, and the transaction manager that was running in the middle tier application. So again, we go through a cycle where the application gets new opportunities, has harder things to deal with, and then we simplify it again through standard transaction-based, in this particular case, 2PC and JTA. And then as we went into the 2000s, SOA and web service applications, SOAP-based communication became more common, and those transaction models were extended to SOAP-based web services. There were new transaction protocols that would define WS-type transactions, being one of them. There have been multiple implementations and solutions to web service transactions provided by both IBM and Red Hat as part of our technology stacks. One of the things, of course, with web service transactions is that web services, more so than co-located or even distributed Java components, were designed to be more loosely coupled. So whilst we can, and we did, extend the notion of ACID transactions to SOAP-based web services, that wasn't necessarily the right thing to do for certain types of web service. They needed a more loosely coupled transaction model. And in the web services space, that was introduced by a compensating transaction model called WS Business Activity, and that's going to be relevant to where we're going in a moment with cloud native transactions and the MicroProfile API. This, in some respects, was a forerunner of what we're trying to build today in Java-based microservices with MicroProfile. What WSBA transactions did was made simple compensating transactions more commonly available to commodity web services. So instead now of having to have a tightly coupled transaction between two what should be loosely coupled web services, we have a loosely coupled transaction model based on compensation handlers, where the application developer, web service A and or web service B, only has to provide an application-specific compensation handler. So it is the application developer's responsibility to provide that error handling. It's not as simple as the infrastructure just rolling stuff back. So the pink box with the error handling does get a little bit larger. it's the scope of the complexity is constrained just to what an individual web service needs to do to make itself right if the overall infrastructure in which it is running determines that the overall transaction has failed and directs that web service to compensate. The majority of the complexity is deciding, first of all, that compensation needs to occur, and then ensuring that the outcome to compensate is reliably delivered to all of the web service transaction participants. That's what the WS business activity transaction model did, and we've had that capability in WebSphere since the 6.1 release, about 10, well, more than that, 15 years ago now. And that's a model for where we're going with containers and microservice transactions. So let's talk about running microservices now in containers. All the transaction models that we've talked about before, from local transactions upwards, can run in containers. If you modernize a complex monolithic application today by breaking it down into component microservices that each run in their own container, then the scope of any transaction used by that monolithic application essentially constrains the choices you have when breaking that application down. The picture that I'm showing here works. So, you know, you've got a microservice, it's running in a container. In this particular case, it is accessing multiple backend, I've drawn it as databases here. And that works because the microservice itself is running in a single container. And, you know, when you're running in a single container, you're not distributing transaction between multiple containers. That's completely recoverable. Even as you scale instances of that container up and down, peer recovery can take care of that. And the transaction model works so long as you don't span it across multiple container instances. If you were to try to break that, go back to that picture there, because that picture is, because this microservice is accessing two different data sources, that's a kind of strange way to think about a microservice. A microservice would typically encapsulate all of its data and interact with one backend persistent store if it needs persistent data. So if you try to break that picture down into two microservices that logically encapsulate the data in one database each, you can do that, but you're going to end up still needing to deploy both of those. And I've put microservices in quotes here because they're not really two separate microservices. You're going to end up having to deploy those in the same container instance if they have an expectation that they will interact with data in an atomic fashion. And the reason for that is because they are going to be so tightly coupled together to the extent that they succeed or fail together, that there is actually no point in deploying them in separate container instances because their life cycle cannot be decoupled. There's no advantage with putting those in separate container instances. And there's not actually any difference at all between this picture here and the one we had before. So two-phase commit transactions work within a container, but they really do define the scope of how far down you can break a monolith if you're going through an application transformation to a cloud-native architecture. So how do we get beyond that? If you want to separate, if you really want separate microservices A and B, you need a different transaction model. And that's where MicroProfile long-running actions come in. Just like with WS business activity transaction, if you separate and more loosely couple your microservices and you want a transactional atomic outcome between those microservices in terms of the data that they interact with. Then you need a more loosely coupled transaction model, and that's what MicroProfile long-running actions provide. It provides a compensating transaction model, but one that is very easy for the individual microservices to use. So just before we talk about what LRA actually does and how you use it, I want to put that into the context of MicroProfile just by talking, just to make sure everybody understands what the MicroProfile set of standards is attempting to provide. The MicroProfile is a set of standards that have been around now for about 4 years. IBM and Red Hat have been involved with MicroProfile standards right from the very beginning. We helped create the original standards and the community around MicroProfile. We helped to establish it as an activity in the Eclipse Foundation, and we provide implementations of MicroProfile technologies on our Java stacks, including OpenLiberty, Quarkus, and JBoss. So what the long-running action? So the long-running actions, the LRA specification here is shown in yellow with reactive messaging. What this indicates is that the current release of the set of MicroProfile standards are the blue specifications. So the current version of MicroProfile is 3.3. It is focused on defining simple cloud-native APIs that build upon the most commonly used Java EE building blocks, and transactions and reactive messaging are standalone specifications that augment the core foundational capabilities of MicroProfile at the moment. It's my expectation that in future releases of MicroProfile, these may become core foundational specifications as well, but at the moment they are standalone specifications, but as part of a coherent set of microservice APIs designed to make it simpler to write Java applications. What LRA long-running actions actually provides is, again, focused very much on making that red box as small as possible in your application to make the error handling for more complex transaction models as easy as possible. So here is an example of microservice A. There are really only 3 things that need to be observed here. The first of all is that the book flight method is annotated with an @LRA annotation. Really, what that is saying is that before this method is dispatched on the application, the infrastructure in which the application is running should establish an LRA, or in some cases you may choose to join an existing one. This application is specifically starting or requesting that a new LRA be created. Anybody that's ever written an EJB before will recognize the annotation as being somewhat inspired by JTA annotations in EJBs. It works for container managed transactions. It works equally well for, if you like, container managed long-running actions. And then having created a service with a forward processing piece of logic in the book flight piece of logic, the application developer is required by LRA to provide 2 methods that would be run, or 2 methods, one of which will be run at the end of the long-running transaction, depending on how the transaction ends. So either a method annotated as the complete method for this microservice will be run, or a method annotated as the compensate method for this microservice will be run. It is the responsibility, obviously, of the application developer to provide those methods, but it is not the responsibility of the application provider to decide if and when those methods are run. That's what the platform takes care of, and that's the hard part. So a typical saga might look like this. This is a familiar example, booking a trip. So here we see 4 microservices. The book trip requires new LRA annotation. Other microservices that get invoked down the line, and it doesn't matter whether those are invoked through RESTful interactions or through event-based, they are annotated with an LRA required annotation, so they'll join an existing long-running transaction, and they provide, each one of those microservices provides methods annotated as complete and compensate. If something goes wrong with the overall transaction, all of the microservices that are a part of this are short running. So book flight will execute and then go away. Book hotel will execute and then go away. The make payment microservice fails. At that point, an instance of the book flight and the book hotel microservices are called, and their compensate methods are driven to make the overall transaction right. And again, all the application developer has had to do is to provide that compensation logic. I say that's all the application developer has to do. We're going to see in a moment that there are a few more things that have to be done around that, but from an app dev point of view, that's all they need to do for the error handling in their application. So a very quick compare and contrast with ACID transactions on the one hand and long-running actions on the other. Essentially, the green stuff means this model has an advantage in terms of simplicity, and red text means this model has some downsides. So for example, with ACID transactions, those are isolated. You don't get intermediate state exposed in ACID transactions. There's no logic required to roll those things back, but stuff is tightly coupled. And the consequence of that is you're deploying everything into a single container, and you move to containers on a kube platform like OpenShift. On the other hand, with long-running actions, data isn't isolated. It becomes eventually consistent at the end of the LRA after the complete or the compensate activities run, but at any point during the long-running transaction, the state may not be consistent until the end. But on the plus side, services are loosely coupled, they have an independent life cycle, and the monolith becomes simpler to break down. Application logic obviously has to be involved in the outcome, but because you're not holding database locks, for example, over the entire duration of the transaction, you get higher scalability through less database contention. So there is a little bit more to it than just developing your applications, and that's where in the IBM Cloud Pak for Applications, as well as providing runtimes that include the LRA capability and an LRA service, we have within the Cloud Pak for Applications a set of accelerators for different types of application pattern. Cloud Pak for Applications 4.2 was the version that shipped in June, so this June, 6 weeks ago now. That's the release of Cloud Pak for Applications in which we introduced accelerators. There are accelerators for REST-based web services and event-based web services at the moment. We are currently developing the transaction accelerator that I'm just about to talk about. But the purpose of accelerators in general is to speed up the delivery of multi-service solutions whilst providing checks and balances, so that in our haste to deliver new function, we deliver new function in a robust, resilient, scalable, and managed fashion. So transaction accelerators are a set of capabilities and tooling that use patterns that are established by IBM's Garage service to suggest good ways in which to build solutions. You're not constrained to using an IBM Garage pattern, but each different accelerator in Cloud Pak for Applications has best practice patterns that you can start from, and the transaction accelerator will be adding a new pattern specifically for the purpose of creating solutions that involve multiple microservices across which LRA-based transaction patterns can be used. All of which, of course, runs on our IBM and Red Hat runtimes, and additionally, on top of that, the deployment model is specifically for containers running on OpenShift. So when you consider the additional things that you have to think about for adding transactions into the mix, we started off with a simple example where you have two microservices, A and B, and LRA, long-running action transaction that spans between those. Not only do you have to ensure that your applications themselves meet best practices, the developer has to build a resilient application that exposes health endpoints and provides metrics for the purposes of providing overall telemetry views of their solutions. So not only do the microservices themselves have to be resilient, the microservices have to bind to an LRA service, which is itself resilient, and they have to be wired together in a fashion that can be tested through the different stages of the delivery process. So in the developer's environment, in staging, and in production. So all of those things take time and effort to become repeatable. What the solution accelerator in Cloud Pak for Applications does is speeds that up and makes that as repeatable as possible. So the transaction accelerator that's under development at the moment augments some of the patterns that we already have in Cloud Pak for Applications 4.2. So here is a picture of the solution builder, which is part of the Cloud Pak for Applications solution accelerator, Cloud Pak for Applications accelerator. This one here, so the pattern that I'm showing here is the storefront pattern that's been that's one of the ones that's in our 4.2 release. But this one, which is a Garage created pattern, but this one has been augmented to add a transaction capability. So what this solution shows is, if you look at this on the right hand side, there are 5 microservices that make up the business logic of the overall solution. That's the customer, catalog, inventory, shipping, and order web services. That's on the right hand side. Over on the left hand side, you have the web, or rather in the middle really, you have the web and the mobile BFF, so the back end for front end web services, which expose the overall solution to different client channels, so web and mobile, obviously. The thing that's interesting that I want to call out on this one is that this pattern has now been extended in the transaction accelerator to have a transactional relationship between the order, shipping, and inventory web services. So when an order is placed, something is taken out of the inventory and shipped. And in this particular case, we want an LRA transaction to ensure that when something is shipped, it really is taken out of the inventory. So what we show here is an enhancement that's being developed for the solution builder at the moment that shows connectors between the order and inventory and the order and shipping web services that have a transactions binding to them. And when you add that transaction binding, then those services get the LRA service bound to them as part of the deployment pipeline. So, you know, I said earlier on that in order to try to simplify and reduce the effort of the developer, we want the developer just to focus on what they have to do in their application to complete or compensate the individual microservices. What the solution builder is doing is it's making the overall job of deployment simpler by ensuring that the stacks that each of these microservices are created on are themselves resilient, so they provide standard templates for ensuring that that health endpoints are exposed, that desired metrics are produced. That in this particular case, for the transaction scenario, that the stacks include the LRA capability, and specifically that the microservices that are involved in the transaction are bound, dynamically bound, depending on the environment that they're working in, to an LRA service that will be deployed as part of the solution. So that's under development as a transaction accelerator for Cloud Pak for Applications at the moment. That is initially focused on Java specific workloads, and in fact the MicroProfile specifications are designed, are specifically targeting APIs for Java microservices. But our ambition is multicultural, so you know it's beyond just Java applications. Solutions can be written in a variety of different programming languages. So Node is going to be one of our future extensions to the LRA model in the Cloud Pak for Applications. So we will be enhancing the capability beyond Java for Node by providing an LRA SDK. Well, it's our intention to provide an LRA SDK for Node applications in the future. Obviously, it'll be the same back-end LRA service with just a new node-based client API for node-based applications as well. And then beyond relatively simple patterns for long-running applications between predominantly REST-based services, event-based transactions will then become the next most interesting thing to evolve our LRA support into. So this picture here, and we're almost finished. So if you've got questions to come, I'm going to stop talking in about 3 minutes. If you look at the opportunities for failure in a simple REST connected scenario, if you have a caller over on the left-hand side of this sequence diagram that calls microservice A, waits for a response, then calls microservice B, gets the response back. This is the simplest possible saga that you could imagine. Everything can fail in an atomic manner at any point during this flow, but the opportunity for failure and the opportunity for that compensate to be triggered it essentially extends over the call sequence of all of the caller, microservice A and microservice B. The advantage, or one of the advantages, of a more event-based model is, you know, not only are the microservices themselves more scalable and responsive through the adoption of a reactive programming model and an event-based interaction mechanism, But the failure window, the likelihood of the overall transaction needing to be compensated, the window for that is reduced now simply to the duration of the individual transaction participant. So you get additional value beyond just having a more reactive system. You have a system in which the likelihood of the transaction succeeding is actually greater because the window for failure is reduced. You don't get any more or less integrity, just a higher likelihood of a positive outcome for the transaction. So, you know, over a long period of time, more than 50 years, IBM solutions and engineers have been at the forefront of information management, transaction processing, and application hosting. We've been doing it for longer than anyone else. We understand the need both for robust systems, but also for practical ways to build solutions to complex problems that are easy for developers to create and which stand the test of time. There's no point coming up with you know, the smartest, most robust transaction model in the world if it requires such a high degree of understanding of transaction processing. Use it that applications become impractical to exploit that transaction model because they're too complex. So there's a balance between providing something that's really, really robust and something that's really, really easy to use. It is all about reducing the size of that red box and the amount of error processing that application and microservice developers need to worry about. We're standardizing all of this with our runtimes on OpenShift as our hybrid cloud platform that runs everywhere, and extending, you know, providing that simplicity not just through the API as defined by the MicroProfile standard and the runtimes that implement that, like Liberty, Quarkus, and in the future JBoss, but also through the through patterns that we provide as the solution accelerators in IBM's Cloud Pak for applications. So there we go. I did take a little bit longer than 30 minutes. I apologize for that. I haven't been able to follow questions in the chat, but now would be a good time to talk about them.
Thank you so much. I love the evolution of microtransactions, especially having gone through most of those, and seeing where we're at now. So really quickly, I did post in the chat for everybody else that last week, if you missed it, David Harris gave a great demo of the solution builder that Ian just talked about as well. So if you want to go back and view that. And then Rich, I think you're here. Wanted to see if you wanted to hop on quick as well.
Yeah, Rich is here if there are any questions.
Hi, Rich.
Hey, yeah.
All right. So microtransactions and transaction processing. I mean, I know you both have been working closely together and collaborating, or your teams have. So how has that been going, and where do you see heading? Yeah.
So, sorry, where do we see what heading?
Now that you've shown the evolution of microtransactions, and now going further into the future, what are the most asked for features and problems?
So in my opinion, it's going to be the more event-based solution. So I mean, we are starting from, you know, from a simplicity point of view. I think we've done, or we are on the verge of completing a dramatic simplification for the application developer. The infrastructure in place to exploit that simple transaction model at the moment is more geared towards core response microservices. We don't yet, so you know, a next stage of the evolution is enabling that LRA model for wholly event-based interactions, which we don't yet have as a pattern in the solution accelerator. So that's definitely something that will come later.
Yeah, I'll pile on there as well. Definitely event-based systems, distributed event reactive systems definitely seem to be the architecture the customers are adopting. And this is building distributed systems, building asynchronous event-driven systems is complicated stuff, especially when you still need, all of the kind of robustness and resilience that your previous generations of middleware have provided, like Java EE. So yeah, that's going to be a real challenge for us to ensure that we can make these building these systems as simple as possible for developers. Because again, moving from programs to distributed systems is huge. You're moving to cloud native, moving to a whole new set of development tools is going to be a pretty significant learning curve. So yeah, investing around developer tooling and providing those guardrails to make it as easy as possible is both Red Hat and IBM.
I can see a question in the chat about where the garage examples are. So what one of the things we're trying to make more consumable is how to actually use the architecture patterns that the IBM Garage creates. So each Garage architecture pattern is described with standard collateral around it in the IBM Garage architecture set. Each pattern that is described there has an exemplar that is backed by a GitHub project. But before we introduced accelerators into Cloud Pak for applications, there was nothing that you could do. You could read the architecture center, you could extract stuff, and you could pull it together as described by the article and make it work. But there wasn't any tooling that helped automate the creation of an application that used that pattern, or provided any pipeline building tools to push that through into a container-based environment like OpenShift. That's what the solution accelerator is trying to do. One of the things it's trying to do. So the short answer to the question is yes.
So I just put a link to the event-driven reference architecture from the Garage into the chat.
Thank you.
Yeah. So I was going to ask you also, what is the most frequently asked feature that your customers, that you haven't gotten to yet, that your customers keep asking about, that you really would like to get into the product?
So the accelerators are the most frequently asked. There are so many different ways I could answer that question that wouldn't be helpful. So for any solution that runs on both OpenShift and Cloud Pak for applications, we do have some gaps at the moment on air gap install. That's the one, and some of that is on the IBM side. Some of that is on the OpenShift side. We probably have more to do on the stuff we're adding on the IBM side, but an incomplete air gap install is the thing that comes up most often, and we really do need to get on top of that.
Well, would love to find out more about that after the session. But I know, you know, for everybody out there, a couple things like OpenShift pipelines we have a workaround for air gap install, and that should be coming out soon. So things like that.
Oh, and we have, you know, we have answers.
Right.
You know, so it's not that we don't know how to do it. It's just that until it's done, we're going to keep getting asked.
Right. Well, and just like the evolution of microtransactions and microservices, the whole evolution of Kubernetes and the whole platform, and we keep going through these cycles, and now we're getting back to all the enterprise grade features and, you know, getting production.
Well, that's right. I mean, you know, I have a transactions background, and up until not so long ago, a transactional capability for microservices was, you know, we continued to think about it as a bit of a dark corner edge case for very advanced scenarios, but we kept getting asked about what to do about existing applications, monolithic applications that use transactions, and just having an answer. You know, there doesn't have to be this answer is right all of the time. There does have to be an answer that says in our it is our belief that this pattern is a good pattern to take a monolithic application and when you break it down into multiple microservices, here is a way in which you can cope with your previous use of transactions. You are going to have to do a little bit more work. This is the little bit more work that you're going to have to do, but it isn't that difficult. We could have taken, and many people do, take a much more revolutionary approach to you know, what's a really good pattern for building transactional microservices using, you know, patterns like CQRS, event sequencing, and you know, there's, you know, those are good patterns that have been around for a long time, but they're complicated, and that's not necessarily what people want to start with if their starting point is an existing application, an existing monolithic application that they're trying to break down into smaller parts. So this is very much a balancing act between enterprise capabilities, but familiarity with what has gone before and simplicity in moving forward based on what you already know.
What about you, Rich? Do you have thoughts on that?
Yeah, I think you summed up pretty well. I mean, yeah, I think we've seen, what you typically see with kind of new waves of technology is people very quickly kind of throwing off all the things we were able to do, and kind of dismissing them as not relevant anymore. And I think we saw that with transactions. I think people, as we've seen the kind of microservices and cloud native kind of curves, people have adopted and they've tried building out applications. They realize a lot of the existing capabilities they have, they still need in these new architectures. So this is a kind of typical whiplash effect we get in tech. Some of the technology that Ian's been talking about, the LRA stuff's been around for a while, but I do think it's going to find a sweet spot now as people start building these distributed applications, active event driven. So could well be good timing for this technology.
Okay, I just got the word that we're still good on time. Unless you have a hard stop, we have a few minutes.
Sure.
Okay. All right, so I know at least in the OpenShift platform, we still have to balance, right, the hardening the platform, making it more robust with all the new features. And how are you balancing that with Cloud Pak for apps?
Well, yeah, so, and that's why that's why the accelerators are a tech preview capability at the moment, because we are trying to manage that balancing act. We expect it to take a little while to get more feedback on these capabilities and to enable us to better harden them before we actually commit to making these accelerators a fully supported capability. So I think the idea of getting technology out there early, but declaring it as a tech preview capability, which is something OpenShift has been doing right since the very beginning, is a good way of balancing those two concerns.
Nice. And how do you collect that feedback? Through the garage?
Do you know, so sorry, I can't see it. Am I sharing a join the CAB screen at the moment?
You are.
Okay, so from a WebSphere and Cloud Pak for Applications perspective, we have a customer advisory board. So I'm glad you reminded me to talk about this. This is one of the most common ways that we get feedback about capabilities that our customers want. It's a means for us to share some of our pre-delivery ideas with them, to sort of a litmus test of customers that we know and trust. So this is a good mechanism, and anybody that is interested in providing input or feedback to our plans as to whether they think they're a good idea or playing crazy, the customer advisory board is a good way to do that.
Nice, thank you. And you mentioned the team accelerators for teams. Then there's the transaction accelerator. Are there any other accelerators that you're tech previewing? So
at the moment we have at the moment we have a cloud native accelerator, the event-based one that David demoed last week. The in development one at the moment is the transactions one, and there are others that are on the drawing board. The transactions one is at the top of the list, top of the backlog. There are other ones, yeah, but that's so we've looked at so we have patterns around which we would like to build accelerators for things like blockchain, edge computing, an accelerator that unifies some of IBM's integration portfolio projects. So things like API management and our apt Connect products don't have an accelerator at the moment, but it's desirable for us to create one. But transactions are a pattern that we see a gap and an opportunity.
Nice. It would be great to get some deeper dives on those accelerators when you're ready in the future. It's from the demo last week. It sounds like something people will really be interested in use. I know we're a few minutes over. Does anybody else have any other questions, or Rich, Ian, any final departing remarks?
Not from me. I do need to drop to another meeting.
Yeah, so I won't hold up the recording any further because I spoke for at least 15 minutes longer than I planned. So thank you, and thank you for inviting me.
Thank you so much. Really, really appreciate it. It was great information. And okay. Thank you everybody else for joining another OpenShift Commons. Again, next week, next Tuesday, we will be here again, same time, noon Eastern, and we will be talking DevOps with Cloud Paks for apps. So join us then. and talk to you all soon. Thank you.
Thank you.
Recording has stopped.
All right. Thanks, everybody. Bye.